So we talk about conduction is the transfer of heat from molecule to molecule. Convection is transfer of heat by bulk motion. It can be of two kinds, natural and forced. Natural, we all feel it, the hot air rises by itself because of the lower density, and then the cold air will substitute the hot air. That's a natural processes, which is also, as we will see later, is the cause of production of the wind. The forced convection means, by some kind of pressure difference. When you blow on something, you're creating a pressure difference. So that would be called the forced convection. Forced convection, of course, is more important than natural convection when we are trying, to remove the heat from a substance, like inside the heat exchanger. These are the couple of examples of how different animals adjust their body temperature and they're dealing with the cold and heat. The slide at the right, the polar bear, is maintaining the heat basically by reducing both the conduction and convection. The conduction is a thick, the layer that he has, so it prevents, the heat from diffusing inside. And then because of the flare that he has, the air inside the flare, it's stagnant, and the air has a very, very low thermal conductivity. So that means, the heat cannot get, to the body much very fast. So that's mainly by conduction. In the case of the alligators and species like that, the animal is spreading. By spreading, it's trying to removing the increasing the surface area, and the wind, when it's passing, the animal is going to remove the heat, much faster. So this one is by convection mainly. A dog can get rid of the heat by sticking his tongue out and basically allowing the larger surface area as the air passing by it, and the heat is being removed by convection. So you can see that the modes of the heat transfer, they're helping in maintaining the temperatures of various species in different ways. Radiation, we said, is in the form of waves, and waves have a frequency and they have a wavelength. You can think of a wave as a sinusoidal form between the distance between the two peaks or two troughs. It's called the wavelengths. The bigger the wavelength is, that will be the lower the frequency. It's a long distance that they have to travel, and so the total number of this wave per unit time will be decreases. The reason is that all of these wavelengths, they have the same speed, so-called the speed of the light. That's the electromagnetic wave. Since the speed is constant, the larger wavelengths means lower frequency, and lower frequency means lower number of the waves that are passing by. That means they can only carry less energy. So the rule of thumb means that higher wavelengths means lower frequency, lower energy. Higher energy means higher frequency, lower wavelengths. In the slide in the bottom here, you will see that gamma rays, they have very, very low wavelengths. So they have a lot of energy. And if we move toward the right, we go from gamma ray to X-ray to ultraviolet, the frequency will dropping, the wavelength is increasing. Eventually, we'll get to the region which we call it the visible wavelengths. That's the region we'll see all the different colors, rainbow colors, starting from the violet and getting all the way to the red. You can see from this slide, the violet has a higher frequency than the red. That means the blue color is warmer than the red color. This is in contrast to our general concept that we always attribute red to hot and blue to cold. Has to do with the historical reason that blue was the color of the water and the red was the color of the fire, so that's how we distinguish that. Today we know that a blue color flame is warmer, hotter than the red color flame. As we move to lower and lower energy, we'll get to the infrared, or we call it heat basically. Eventually, the infrared will give way to the microwave, which have a lower energy, and ultimately to what we call it communication or radio frequency, which are the TV and radio. Radio frequencies, they have very low energy, of not of our concern in this course, because we're dealing with the transport of energy for producing power. What we usually call thermal radiation is a region which is in the infrared, visible, and ultraviolet, and that's called thermal radiation, which gives us the sensation of the heat. The part which is gamma ray, X-ray, and also a portion of the ultraviolet, these are very, very energetic energy, and these are usually coming from the some kind of nuclear reaction. So we'll deal with this when we talk about the nuclear reaction. These are called also ionizing radiation, because they can affect your genes and can cause, the mutation inside the gene, and we'll talk about that later. This diagram shows the amount of radiation of some objects, in this case black objects, at different temperatures. The top curve is the sun. Radiation of the sun, you can see, is peaking in the visible radiation and very rapidly is falling off toward both end, toward the red or the infrared, and also toward the higher intensity radiation like the gamma and X-ray. If you look at the lower curve, is a terrestrial radiation, is a body which is at the room temperature, about 300 Kelvin. That one, the peak is about 12 micron is way outside the visible range. That's why we do not see that the radiation or the heat coming from objects, from the bodies that there are around the room temperature. Our body is slightly higher than room temperature, but the peak radiation from our body is outside the visible range. That's why to observe my body, we cannot see it without the light. What we see is the reflection of the light source from my body that you see. If you turn off the light, then not much can be seen, so you need a special camera, which is called basically night vision. The curve in the middle is some kind of combustion products. Okay, combustion products, you can see, has some component in the red and has some component in the blue, so depending on the temperature you'll see more red or more blue or vice versa. This is a body which is being viewed by an infrared camera. As I mentioned, the radiation from the body is in the infrared, so this is being viewed by a special camera. The colors are artificial, and what they represented here, basically in the infrared camera, we only see that the black or white, and here they have colored it artificially to represent the areas which are the colder in blue, which are redder, in this case the necks and armpits and hands are warmer part, and these are in red. And the scale at the right will tell you what is the temperature in degrees Celsius. I would recommend you that you see these videos, which gives you a good representation of different modes of the heat transfer. You can watch it on your own time. These are some questions. I would like you to answer them, and then in the homework problem I will ask you to give the answer to this problem, and so you will have that eventually graded. These are more examples. I would recommend that you try to answer them or come to the discussion sections and discuss them with other people, friends in your class.